The student of class 11. Today also I'm continue with the complex number, and today's questions are very important for your examination point of view. Now this concept of this question, show that 1 plus I divided by 1 plus 1 by I is purely imaginary number. Find the amplitude of the number. Now this you have to prove this quantity is purely imaginary. Now how to prove this quantity is purely imaginary? After the simplification, its output must contain I. After the simplification of this function, the output must contain I. Then we can say it is purely imaginary. Purely imaginary. To prove this one is purely real means the output must be independent of I. Then we can say it is purely real. If the output contain I means it is purely imaginary. Now then I'll simplify this equation. First of all, I'll represent it by z. Z equals to 1 plus I divided by 1 plus 1 by I. Then I'll simplify 1 plus I divided by, I'll take LCM over here, it is I plus 1 over I. Now then 1 plus I, it's a division form. I'll write multiply I over 1 plus I. Instead of writing I plus 1, we can write 1 plus I. This and this get cancelled. It is I. Z equals to I means this is imaginary. Therefore, we can write Z is purely imaginary number. The Z is purely imaginary number. Find the amplitude. Amplitude means, now say Z equals to I. To calculate the amplitude, let theta be the amplitude. Then tan theta is equals to y by x, or a by b we can write. Okay, it would be better. I'll write b by a. Tan theta is equals to b by a. To calculate the amplitude, that you have to calculate the value of theta. In this complex numbers, now say, I'll write once again, I'll write this is better. I'll write over here. Now say z equals to I. Then we can consider it is 0 plus I into 1. Raw form I'm doing over here. 0 plus I into 1 means a plus ib. A is 0, b is 1. Then tan theta is equals to b is 1, a is 0. Any number divided by 0 is undefined. Then the value of tan undefined is tan 90 degree, that is pi by 2. Removing tan from both the sides, it is theta is equals to pi by 2. So, this is purely imaginary, and this one is the amplitude. This one is the raw form. A plus ib form, just I'm showing. Now dear student, another very important question. If mod of z equals to 1, then prove that z minus 1 over z plus 1, z is not equals to minus 1 is purely an imaginary number. This question is also related to the previous one, that you have to prove z minus 1 over z plus 1 is purely an imaginary number. Means after the simplification, this value z minus 1 over z plus 1 must contain I. Then only we can say it is purely an imaginary number. But over here only z is given, that you have to consider, let z equals to x plus iy, any complex number. Now then I'll simplify this one. Since mod of z equals to 1, then substitute the value of z. Z is x plus iy equals to 1. You remove the mod, that you have to reuse square root. X square plus y square equals to 1. Then squaring both sides, what you will get? X square plus y square equals to 1. Or you can say x square plus y square minus 1 equals to 0. Let it be equation number 1. Now to prove this quantity is purely an imaginary number, z minus 1 over z plus 1, I'll substitute the value of z from this relation. It is x plus iy minus 1 over x plus iy plus 1. Now then I'll write the real and imaginary quantity. The real is x minus 1 plus iy, I'll separate, over x plus 1 plus iy. Now, if the complex number, two different complex number are in terms of numerator over denominator, to simplify such kind of complex number, that you have to rationalize this quantity. Always rationalize the denominator. Now it is x minus 1 plus iy into x plus 1 minus iy. Rationalization. Again, x plus 1 plus iy into x plus 1 minus iy. Now then I'll open the bracket of the numerator. I'll multiply these two quantities. It is x minus 1 into x plus 1 minus, if I multiply these two, then it will be I into y x minus 1. Then I'll multiply these two, plus I into y x plus 1, plus into minus, minus I into I square into y square, divided by, the denominator is in terms of formula, a plus b into a minus of b. It is a plus a minus b whole square. Now this one is also in terms of formula, a plus b. A minus b means you can write x square minus 1 square is 1. Now from these two expressions, I'll take iy common, plus iy common I'm taking. If I take plus iy common, then I'll write this x plus 1, then minus this quantity, it will be minus x plus 1, minus, it will be I square equals to minus 1, minus into minus plus y square over minus I square into y square. This and this get cancelled. Now then I'll write the real quantity together. X square plus y square, then minus 1, 1 plus 1, 2. It is I into 2y divided by I square is minus 1 plus y square. Now then I'll use relation number 1, equation 1. So the equation number 1 will already derive this quantity, x square plus y square minus 1 equals to 0. Now the same thing we are getting over here. X square plus y square minus 1 is 0. In place of this we can write 0 using equation number 1. 0 plus I into 2y divided by plus y square. Now then after this, can write I into 2y over x plus 1 whole square plus y square. Now this one is the final result. The final result contain I, means this final result contain I means this quantity. Therefore z minus 1 over 1 is purely an imaginary number. The student, another important topic, the locus of a complex number. Locus of complex number. Now say the locus, how to calculate the locus. Now say I'll give you the concept or anti-concept of the locus. Suppose after the simplification, the first locus, after the simplification, if your answer is in this form, ax plus by equals to c. If your answer in this form, x is linear, y is also linear, in this case that you have to write ax plus by equals to c, means this one is the straight line. Therefore, if you get the answer like this, therefore you can write locus is a straight line. Local is a straight line, and x-intercept and the y-intercept that you are going to calculate. To calculate the x-intercept, put y equals to 0 in this equation. Then you will get ax, y into b, 0 into b is 0 equals to c. Then the x-intercept is c by a. To calculate the y-intercept, then you have to put x equals to 0. If you substitute x equals to 0, means by is equals to c, then y is equals to c by b. This is the x-intercept and the y-intercept, the first locus that you get, this kind of locus. Number 2 locus that you get in this form, y square is equals to r square. Now actually x square plus y square is equals to r square means the locus is a circle. Locus is a circle whose center at the origin, you just have to remember, and radius equals to r log x. This kind of, you get this r, this is center, 0, 0, the locus. Now number 2, third is, you may get x minus alpha whole square plus y minus beta whole square equals to 0, r square. You'll get the locus in this one. Again, in this case also, locus is a circle, center is alpha comma beta, and radius equals to r units. One more circle is there, locus. Suppose your answer is like this: x square plus y square plus 2gx plus 2fy plus c equals to 0. Locus is a circle again. Three different types of circles that you get. These two are actually similar. Locus is a circle, center is minus z minus f, and radius equals to under root g square plus f square minus c units. But these concepts are there in coordinate geometry. When I'll start the coordinate geometry, everything we'll discuss in that chapter also. This is the concept of locus. The student, the next question is question number 18, the application of locus. It is given the complex number is z equals to x plus iy, and the relation mode of z plus I over z minus I is equals to 1 by root 2. Find the locus of this complex number. Now we'll try to find the locus of this complex number. Complex number is already given, x plus iy, then I'll write over here, or z is x plus iy plus I over x plus iy minus I equals to 1 by root 2. Or I'll separate the mode as well as the root mode. Then x plus, I'll take I common. If I take I common, it will be y plus 1. From the denominator also, I'll take I common, it will be y minus 1. Root 2. Mode is there. When you remove the mode, then you have to put a square root of x square plus y plus 1 whole square divided by under root x square plus y minus 1 whole square equals to 1 by root 2. To remove the root, what we are going to do is squaring both sides. Then after the squaring both sides, the result will be x square plus the root will remove, by 2. Now after this, that you have to cross multiply this quantity, or it is 2x square plus 2 into y plus 1 whole square equals to x square plus y minus 1 whole square. After the cross multiplication, we'll get this result. Okay, now then I'll write the like terms on one side. Now first I'll have to use formula over here, or 2x square plus 2. I'll use a plus b whole square formula. It is a square plus b square plus 2ab equals to x square plus, this one also, a minus b, a square plus b square minus 2ab, or 2x square plus 2y square plus 2 plus 4y is equals to x square plus y square plus 1 minus 2y. Now then, I'll write the like terms on one side, everything on one side, or 2x square minus x square, this you have to bring, plus 2y square minus y square plus 4y plus 2y plus 2 minus 1 equals to 0, or it is x square plus y square plus 6y plus 1 equals to 0. Now over here the locus is a x square plus y square plus 6y plus 1, means it is in terms of this form. I'll do the rough work over here. Now this equation is in terms of this form: x square plus y square plus 2zx plus 2fy plus c equals to 0. Now it is in terms of this form. That means this is a circle. Locus is a circle. Then we'll calculate the value of g and f to calculate the locus is a circle, to calculate the center and the radius. Now sir, over here, compare this to equation: x square, y square, x. The coefficient of x is 2z. Over here the coefficient of x is not there. That means x, the coefficient of x is 2z. Over here the coefficient of x is not there, means we can write therefore 2z is equals to 0. No coefficients are there. Now sir, the coefficient of y is 2f. Then 2f. Over here in this equation the coefficient of y is 6. 2f equals to 6. And the constant c, over here constant is 1, means c is equals to 1. Then z is equals to 0, f equals to 3, c is equals to 1. After getting g, f, c, then we can write therefore locus is a circle, center is, formula I've already given you, minus z minus f. The center minus z into 0, it is 0, minus into f is 3, it is minus. So center is 0, minus 3, and radius equals to under root g square plus f square minus c. Then substitute the respective value. 0 square is 0 plus f is 3, 3 square is 9 minus c is 1. It is under root 8. Under root 8 means we can write 2 root 2 units. Therefore the locus is a circle whose center is 0, minus 3 and the radius is 8. The similar question you can try homework, question number 14.2 you can try at home. Now sir, again the complex number is a very vast chapter. Again in another video also I'll continue with the complex number, and this much for today. Thank you.